Yeah, we have the descriptor file which we calculated. So the next step was we have a particular data set, right? So we divided our particular data set into training and testing, right? So we have a particular algorithm which Abhi just said, that we have the J48, the random forest, the SMO, and these are different classifiers, and as the name suggests, they classify compounds into active and inactive, right? So we divided into usually the ratio is 80-20, 80%, 20%. 80% is the training and 20% is the testing. So what we did was we split the file. We can do it in Weka. We can split our data set into training and testing. But what we did was we had a Perl program. It was a simpler Perl program, and we can do it with any program. We can split it. We can do it manually as well. There are many different tools, but the thing is, since we were testing, we have. It's a repository. It's a repository of many classifiers in one particular.
There is no other tool like Weka, what Weka is providing. It contains more than 40 classifiers. So we selected that Weka. At instance, we can use more than 40 classifiers.
So one more thing is there, that Weka is the only tool that is having a graphical user interface for data mining things. So that becomes a very user-friendly in understanding the classification algorithms.
Okay. So as of now we have sorry. I'll have to look into it actually because the time is.
No, it won't be name of the tool. Like you are going for classification algorithms, so it will.
It's an algorithm.
No, there is no such tool. Like where you can get an.
You have some command prompt tool.
No, I didn't say that.
There is a GUI.
Yeah, it's a GUI.
There are other softwares to do this.
That is Weka is also command based, and it also has a GUI. It makes it a user friendly thing. But what you are asking, that there are other tools also to do this, that we haven't actually searched for it. There would be segregated, like you are having classification algorithms, naive based. It will be working separately. You can write a Perl program to build a model from that also. Okay.
Yeah, like I said, now the first thing we have to train our particular classifier. So what was done was that we fed our training file into the different classifiers, and we searched for what Weka does. It creates a confusion matrix. It says how many are true positives, how many are true negatives, how many are false positives, and how many are false negatives. So I believe everybody knows what true positives, false positives are, right? So the basic threshold, which we said that up to the we can there's one more concept of applying the classification cost for the false negative. There's a very simple concept behind this. A false negative is an active which is being classified as an inactive. You can't let that happen. So there's a concept that you can acquit a criminal of some charge, but you should not accuse an innocent, right? So this is the main reason. We don't want the the actives to be classified as inactives. So what we did was we set a penalty. It's sort of a penalty on the false negatives. So whenever we said that the true positives, we have to increase the true positives as long as the false positives stay below the 20% range. And with that, we applied the misclassification cost, which I think Kumar would explain much better. So this is the main reason. And once we had that particular algorithm trained for our testing, we applied the testing, the rest of the 20% of the test, and for all the classifiers, and we chose the best model, which gave us the highest number of accuracy, and we're getting around 80%, 85% of accuracy. and with the large number of true positives with less number of false negatives. And how did we do this? Using these particular tools, which Vinita would continue from. Thank you.